Alright, so this first page that we're going to go through, you don't actually have to note it because I know that there's a lot of writing. I'll just scan this one and put it on sector. From the second page is when you guys can start actually noting what I'm writing here. So basically, I just want to go through the structure of a matrix and just recap a couple of things we spoke about last lesson. So remember, when we talk about order, we're basically talking about the size of a matrix. So if a matrix has order m times n, the m and the n are telling us how many rows and columns the matrix has. So the m tells us how many rows the matrix has, and the n tells us how many columns it has. So if I have a 2 times 1 matrix, it means it's got 2 rows, 1 column. Now, a convention that we can use to label any position in this matrix. So here we've got a matrix. What's the order of this matrix here? It's an easy one because it's got the same amount of rows and columns. The order of this matrix would be a 4 times 4. Now, this here might look confusing for you. You might look at this and say, what on earth does this mean? So all this is saying is in a matrix, I can label any of these inputs using this convention here. So A, I, J, where I can be 1 through to 1, 2, 3 through to M, or J can be 1, 2, 3 through to N. So if I was to look at this number 6 here, right, that element of this matrix is 2 down, 1 across. So I could say that would, well, since this is matrix B, not matrix A, I'll use the letter B, but it would be B, and then the I, since it's 1 down, 1 across, sorry, it would be B1, 1. Alright, or if I wanted to, sorry, it's 2 down, 2 across. So this element here would be B2, 2. This element here we would label B1, 1. Alright, this element here would be B1, 2. This element here would be B1, 3. This element here would be B1, 4. If I came to this one down here, it would be B4, 4. Alright, so this is just a way that we can denote what number is in a certain spot of a matrix. So let's just see if we understand this. So if we wanted to look at B23, what value is inputted at B23? So you always look at the I's first and then the J second. So the I is always first, the J is always second. So if I was to look at B23, we come 1, 2 down, and then 1, 2, 3 across. So can you see that B23 would be equal to B? Alright, the next one, if I have B41, so again, the 4 is going to represent how many I come down, and the 1 is going to represent how many I come across. So if I come 4 down, 1, 2, 3, 4, and then it's in the first column, so therefore B41 would be 7. Alright, can we see that these subscripts are telling us which position a certain input is? So this here, B22, we look 1, 2, 1, 2, so it would be 6. Alright, or if I had B13, so it's going to be the first row, 3 across, so it would be the 8. Or if I had B32, I come 3 down, 2 across, so it's the third row, second element, so it would be 7. And then the last one, B34, 1, 2, 3, 1, 2, 3, 4. So that one would be 21. Alright, so that's just a little way that we can denote what number is in a certain spot of a matrix. So you just need to be aware of that. I don't want you to necessarily write that. Like I said, I'll scan that page because there's a lot of writing there just to show you a bit of a convention. Does anyone have any questions about that? Alright. So from now, I'll actually get you to write what I'm writing. So we're going to look at some matrix addition and subtraction actually. Matrix addition, and subtraction. Alright, so Ethan, we're noting this. Is there actually anything on your laptop that you need for maths right now? Alright, so can we short it? Alright, so to add or subtract matrices, they must be of the same order. So remember, order just means the size of the matrix. So if I've got a 3 by 3 matrix, I can only add it with another 3 by 3 matrix. Or if I want to do a subtraction of 2 matrices, they have to, maybe they are both a 2 by 2, or maybe they're both a 2 by 3, but they need to have the same order. If they're not the same order, we cannot do a subtraction or addition of those matrices. So I'll show you what I mean. Example. So we're going to write out 3 matrices. We're going to have matrix A. So matrix A is going to be a 2 by 3. This is 1, 6, 2, 5, 3, 4. So would we all be comfortable in knowing that how to say the order of that matrix? Remember, you say the rows first, column second. So that's a 2 by 3 matrix. Then we're going to have matrix B, which is equal to 2, 0, 1, 3, 6, 5. So what's the order of that matrix there? Again, 2 by 3. And then the last one, we're going to have 3, 2, 1, 4. So the order of this matrix is, good, 2 by 2. Alright, so for our first one, we're going to do a matrix addition. We're going to go A plus B. So I want to go matrix A plus B. First off, is this going to be possible? What was the one condition I said that needs to be satisfied for us to be able to add matrices? They need to be of the same order. A and B of the same order. Yes. So I'll start out by writing each of the matrices again. 1, 6, 2, 5, 3, 4. Plus B, which was 2, 0, 1, 3, 6, 5. Now when we want to add 2 matrices, we basically are just adding each of the elements which are in the same position. So I'd go 1 plus 2. See how they're both in the position 1, 1? Alright, and then the ones that are in position 2, 2, I add those ones. The positions 1, 2, I add those ones, and so on. So this would be equal to I'm going to go 1 plus the 2. See how they're in the same position in each of the matrices? The 1's there, the 2's there. Then this one here would be 6 plus the 0, because they're in the same position. Then the 2 is going to be added with the 1 because they're in the same position, and so on. 2 plus 1, 5 plus 3, 3 plus 6, and 4 plus 5. And then you can shut that matrix. And then it's just a matter of doing those additions to find what the final matrix is. So you just go through and do each of those. 3, 6, 3, 8, 9, 9. Alright, simple enough.
Do you then add them into a formula after that, or just leave it like that?
That's just going to stay as it is. So that's our resulting matrix, A plus B. Alright, so next we're going to use the same, we're still going to use A and B, but rather than going A plus B, I'm going to go A minus B. So A minus B. Would you guys feel comfortable to do that in the same way that we did the addition? So again, write out your matrix A. 1, 6, 2, 5, 3, 4. Minus B, which is 2, 0, 1, 3, 6, 5. And again, when we're doing the subtraction, we just have to consider each of the elements which are in the same position. So we'd go this 1 minus that 2, that 6 minus that 0, that 2 minus that 1, and so on. So this will be equal to 1 minus 2, 6 minus 0, 2 minus 1, 5 minus 3, 3 minus 6, and 4 minus 5. So you're following along. Each of the elements which are in the same position are the ones that get subtracted. Now, notice that some of these are going to become negative numbers. That's not an issue. We can have negative numbers in a matrix. So that's equal to 1 minus 2 gives me negative 1. Alright, so 1 minus 2 is negative 1. 6 minus 0 is 6. 2 minus 1 is 1. 5 minus 3 is 2. 3 minus 6 is negative 3. And 4 minus 5 is negative 1. My last example is A plus C. A plus C. Now, if we just have a quick look, if I went to add these two matrices, A and C, can anyone see an issue? Good. Are they of the same order, those two matrices? No. This one's a 2 by 3, that's a 2 by 2. Therefore, we can't add them. We can't do a matrix addition if they're not of the same order. So you just write this sum cannot be determined as the matrices are of different order. You might want to say that A is in order 2 times 3 and C is in order 2 by 2, but you don't have to. That would be enough in a test just to say that you can't do that addition because the matrices are of different order. Alright, now the last thing that I'm going to introduce you to is a zero matrix. So all a zero matrix is zero matrix is a matrix in which all the elements are zero. E.g., if I had a 2 by 2 zero matrix, it would just mean I have 0, 0, 0, 0. Or if I had a 3 by 3 zero matrix, it would just be 0, 0, 0, 0, 0, 0, 0, 0, 0. Alright, so I just want you guys to have some practice in doing some of these additions. So you can do the following: 1A, B, D, 2A and C, 3A, B, C, and 4. So I'll show you quickly what they look like. So see, in these questions they give you, scroll a bit too much. They give you a matrix A, B, C, and then you just have to do some of these additions. So I'm not getting you to do all of them. For question 1, I'm getting you to do A, B, and D. See how there's 3 matrices here, but we've only practiced adding them with 2. It's exactly the same thing. Alright, but now you've just got 3. So you can add the 3 numbers. And then with this subtraction, I would do the addition first and then subtract away that A after you do that addition. Alright, so the ones that you're doing are listed there.